them are just logic questions. What does it look like they're doing, basically? All right, so really quickly, when you get a transformation called a reflection. Oh, wait, I'm sorry, we're doing Miller. So we did this last class. I said translate along a vector. And we said all this really means is that you're taking an x of 2 and a y of 1, and you're just adding those values to the coordinate, the vertices you've already got, the points you've already got. Now, we also said you could draw it out and you could say, well, I'm going to take this point A. So I'm going to take this point here, and then I'm going to take this point here, and I'm going to treat them all separate. Just tell them to pull. They should. You can just pull on the door now. There you go. So you're going to take each point individually, and you're going to go right to up 1. That's what an x of 2 and a y of 1 means. You draw it out. If you don't have the graph already and you understand that this is just adding 2 and 1, that's a lot faster. That's the way I'm going to do this one. So I would just say to each one of these, plus 2, plus 1, plus 2, plus 1, plus 2, plus 1. And that will be where the new vertices are of which figure. So if I do that, I get -1 and -3. If I do this, I get 0 and then 2. And if I do that, I get 7, 0. Raise your hand if you knew how to do that. That's the way you did it. You remember, just add the. Did anybody draw it out and do it? In our class? Yeah. Why? Why? All right, we'll deal with that in a minute. So. Again, if you need to draw it out, that works. If you understand that having positive numbers means right and then up. If it's a negative x, it means left. If it's a negative y, it means down. And then obviously if they were negative numbers, you would add those negative numbers in to whatever the previous. Oh, and we said just as a last, this is your pre-image. Whatever you start with is your pre-image. And then your final thing that has the little prime symbols on it, these little slashes things, that's called your image. So you go from a pre-image to an image. That's another one. You have to understand what they're asking for. You will see that for sure, that notation. Pre-image is the first image, and then you're creating from that the image is the notation you'll see. There's a lot of vocabulary we still haven't done. I'm not going to even try to do it today, because we're going to try to get that quiz done. So here's the next thing we're doing. Again, I'm going to go fast. We're doing reflections today. So we did translations, reflections today. Phones should be up, but try to work today. Today's a pretty easy lesson. You should be able to get this stuff today. So there is a formula you can use for reflections sometimes there's not. I'm going to teach you the way to do it without formula. Then we may come back to the formula and I'll show it to you at the end. But again, they're not going to give you that on the EOC. They don't give you a formula sheet with the reflections formula. So if you just understand what you're doing, I think that's the best way to do it. There's this thing, so just write this down. It's called, this is really what I think they call it in this book. The first book I ever used called it the mirror line. So write line of reflection.
For like the title?
Well, the title is reflections, was your first definition under that. Well, actually, we're gonna define reflections also. I think we sort of did it the other day, but it's been a little while, so we'll redefine it.
Reflecting is basically just flipping an image over the axis.
Well, it's not always the axis. What we're going to talk about today.
But basically,
it is flipping the image. So I'll show it to you real quick. So if we have a triangle here, so if this triangle is sitting right here on this screen, a reflection would either be flipping it this way, or I could also flip it this way. I could flip it left and right. Now it could be anywhere. I could have it on the screen and it could be overlapping the X and the Y axis. And if I flip it over a certain line of reflection, I could flip it like this. I could still flip it like this. I can flip it right. It all depends on what the line of reflection is. That's why I say it all comes down to the mirror line or the line of reflection. So I'm going to show you how to do this really quickly, and then you're going to maybe, I don't know if you'll practice this today or you'll go straight into the the little district assessment thing. So one line of reflection. So let's say we have a figure. We'll start with a pretty easy one. There's your triangle. And again, they could give you an individual point that you reflect. They could give you a triangle. They could give you a square. Not going to give you a circle. They give you a rectangle. But triangles are pretty common. So if you have this triangle, and let's say they tell you the line of reflection, or really what they'll say is reflect over the y-axis. If they tell you to reflect it over the y-axis, that means the y-axis is the line of reflection. So I want you to think about drawing a line. You don't have to physically draw it in, but I'm going to really draw it in. Oh, I should have used a highlighter. That's my line of reflection. I am simply now flipping that image over that. Here's the key. You can't visualize how it would look, which a lot of times you won't be able to visualize it. It's the same for every single problem, for every single, I guess they're problems. It just depends on where your line of reflection is. But once you draw in your new line of reflection, not really new, I mean, once you draw in your line of reflection and you know you're going to flip it over that, a mirror, it's hard to explain. Like, if I have a mirror and I'm putting my hands up, boy, I wish I had a mirror. If my hand is closer to the mirror there and it's farther away here, then my reflection, it's going to look like this hand is closer and this hand is farther away. It's the same thing with this. If a point is closer to the line, then when you draw the new point, it's going to look closer to the line. And I'm going to give you a more specific version of this. So if this is a point and it's that far away from the mirror or the line of reflection, then I need an opposite point. So let's do A, B, C. I need an opposite point for this that is that same distance away. So that is the reflection of C prime, not B, of C. Same way for A. If I'm, and it's easier to see when you only have one point. If I'm only 2 spaces from that line of reflection, I need a point on the other side. The point has always got to be on the other side of the line of reflection. So again, you may want to jot that down. You'll never have a point that's on the, like, create this point on the same side of the line of reflection. It's on the opposite side and it's the same distance away. So that's my A prime. And then the last one, and these are always the ones that are trickiest, the ones farther away, but they're also like on the same grid line is another point. If B is 1, 2, 3, 4 away, then I need an opposite point that is 1, 2, 3, 4 away. And that would be my B prime. And then you just, once you do the dots, then you connect them. You don't ever, we said, try to draw an image and just reflect it over, draw the whole image at one time. You do point by point. So if you'll notice now, if I took an image that was facing this way and if I flipped it to the right, point B would flip out to the right. This line here would become now the inside line, and that's what a reflection would look like if it was over the Y. Any questions on that? Go really fast today and we'll be done in the next 10 minutes probably. And you will not completely understand it, not expecting you to, but you're going to practice probably for 10 minutes maybe, and then we'll do that other quiz. Some of you that are visual will understand. Yes.
When the X, like it's that red triangle was going over X way.
We're about to do that one next.
But when it be like, you know, sunsets on rivers and that, would it be like that? It looks opposite, like upside down.
Kind of, yeah. The higher up it is, the higher or the lower it would really look on the river. We're going to do one though right now. I'm going to use, I guess green will show up good enough. So now that was our reflection over the Y. Now let's just pick a different reflection line because that's really the only thing that ever changes. The way you do it never changes. So now let's say they said reflect it over the X axis. So if they now said X axis, again, I just draw in my line of reflection is the X axis now. It's the same, it's always the same thing.
It's just turning it up.
You look at each point individually and you say, okay, I want to make a point on the other side of the reflection line. I do the same thing. It's just now the reflection line is left and right, but I still need a point. If this point B is 2 units away from the reflection line, I need a point that is 2 units away from the reflection line on the other side. So that would be my B prime. Again, same thing for C. If point C is 2 units away, I need an image or a point on the other side that is 2 units away. There's my C, C prime. Now A is a long way away, right? A is much farther from that mirror line. So when I create a point on the other side, it's going to be much farther from the mirror line. It's going to be 1, 2, 3, 4, 5 away. So from the mirror line, I count 1, 2, 3, 4, 5. And that would be where my A prime would be. And then you can connect all those things.
Can the reflection point be like off the X and Y axis? Like,
Absolutely, we're about to do
Yeah.
one of those. Or it can be all kinds of stuff. There's one where you're going to actually reflect it over this line, X equals Y. That's probably the hardest one. Or Y equals X, or negative Y equals X, or negative X equals Y. That's by far the hardest. I don't even know if we're going to try that one today or not. I'm going to probably just stick with either X or Y axis, or they might give you a value for X or Y and say that's your reflection line. And kids will get that confused sometimes. Just remember, if they say over the X-axis, then your reflection line is the X-axis. If they say over the Y-axis, then you draw the Y-axis as your reflection.
can it be like that, like from the top left corner to the bottom?
Yeah, that's what these are. This is a
Oh.
diagonal line
Oh,
right
yeah.
there. So I probably won't get to that today. So now, any questions on over the X-axis? Again, you just draw the X-axis in your mirror line. It's all about, or I'm sorry, the line of reflection. It's all about making the correct line of reflection. I'm gonna not get super difficult yet. We may not even do these other ones today. So now let's say they want you to reflect it over X equals -2. So not an axis, not a Y or an X axis. Just over X equals -2. Nothing changes. You just need to make sure you draw the reflection line in the correct spot. Where is X equal to, oh, I don't want to do -2. I'm sorry, +2.
You're just pushing the line of reflection right in that surface.
Oh boy, that's not actually a good one either. Let's change that so it's not super difficult. Let's make it X equals 1. What do I need to do if I want to reflect it over X equals 1? I just got to figure out where does the reflection line go. It's always about drawing the correct reflection line. Once you do that, it's always the same. Create a point that's on the opposite side, the same distance away. Now, if this is where the first mistake kids will make, if it says reflected over X equals 1, they think, oh, well, you know, X equals 1. X is the horizontal axis, right? But if we're reflecting it over X equals 1, X only equals 1 there. That's the only place X equals 1 as far as like on an axis. That's Y equals 1. X equals -1. But we need to make sure X is always 1. Well, the only way to do that, if you remember back in algebra, this line right here is the line where X is always 1. So X equals 1 is actually a vertical line, which can be confusing because you're used to the Y-axis being vertical, but now X equals 1 is vertical line. So that is your reflection line now. Again, hold on just a second. Ignore the X and the Y-axis. Kids want to, because you're going to get more problems that deal with flipping it over the X and the Y-axis than any other kind of problem. But if they tell you it's over this, you got to remember to ignore the X and the Y-axis. This is the only line you care about. That is the reflection line. Now you just do the same exact thing. How far away am I from the reflection line? Well, point C is 1, 2, 3 away. So I need 1, 2, 3 away. So that would be C prime. A is 1, 2, 3 away. 1, 2, 3 away would be my A prime. And then B is pretty far away now from X is 1. 1, 2, 3, 4, 5. So I need 1, 2, 3, 4, 5. And you'll notice that the shape should typically look like it's a reflection, like it's been flipped. If your shape looks a little weird, like it doesn't look like it's the same size, because your size never changes. The size of the shape shouldn't be changing. So if you create a new image and you're like, wait a minute, that doesn't look like it's the same size, then you did something wrong. All this should look like is you flipped it over.
With the so the like numbering on the y-axis axis, you wouldn't really care about those, right?
What did you say now?
So like the y-axis and the x-axis, the number sign, like 1.
You're talking about the number line?
Yeah. That doesn't really
There's a
matter.
way to do a formula using those and using the actual ordered pairs, and we may get to that another day. Problem is that gets confusing and it's different formulas depending on what kind of, well, not easier because you got to memorize all of them. I guarantee you people are going to get some of them confused. So if you understand what you're truly doing, you don't have to memorize anything. I'm always more into the understanding thing. Any questions on that? So I'm going to do one more, and then I'm just going to let you practice. I won't do the most difficult ones today. We'll do those another day. If you get some of them, I might do them individually. So now, what if it says flip it over y equals, we'll do y equals -1. So flip it over, y equals -1. What kind of reflection line am I drawing?
You're reflecting it over the x-axis.
No, I would have said x-axis. I mean, it will go
Probably
over the
not.
x, but you got to ignore the x. If they don't say reflected over the x-axis or y-axis, you ignore that. That's the reflection line, this line,
Oh, it reflects on the negative.
where y is -1. So what's that line look like?
It's gonna be a horizontal line that follows line of negative.
That's where y is -1, right? So we need to draw a line through that. Now, if we drew it vertically, that wouldn't make sense. I hope that doesn't make sense because that would be the y-axis. So that can't be where y is -1. So the only option really is to create a line that goes like this. So now we're going to reflect it just like we did when we did the other reflection up and down. It's just do not use the x-axis. Kids always want to go back to the x and the y-axis. Once you've created a new reflection line, that's the line you use. That's why I say it's all in making sure you know how to create that reflection line. If y is -1, this is where the reflection line would be. Now we just count distance away again. So B is 1, 2, 3 away. So 1, 2, 3 away over here. C is 1, 2, 3 away. So 1, 2, 3 away over here. Hopefully this one still fits on the screen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, pretty close. 6. And then you just connect them. And again, if you look at the shapes, you should be able to say, yeah, those shapes are the same size. Sure, that one's been flipped, but it's still the same size. Now, kind of like I told you, but well, actually, I'm not even gonna do it. I like that better for now. Maybe we'll do shortcuts later. We do the formulas. So go ahead. Get out. 10, 49.
That's
Practice. So I'll just tell you, these are the reflection IXLs. So you may want to jot those down because you're going to practice on your own, not today. In the class, we're going to go straight into the quiz you're taking. So jot those down, or if you just, I've already recommended them to you in IXL. So if you just look for the ones I recommended and say reflections. There's a bunch of other ones for transformations. I recommended every transformation IXL already. But the only ones that you really know how to do so far are translations. And then you should know how to do some of the reflections, but we didn't cover all of them yet. Here's what you need to do now. Any questions on that before we just kind of get that other little quiz thing, district quiz thing out of the way? Questions? All right, so whatever technology you have, laptop, phone,
There we go.
whatever it is, go ahead, pull that out,
So we're taking.
log into your Clever.